All right, we're moving on to section 3 of chapter 12, and what we're going to do in this section here is we're going to find the area of a specific type of shape, and that is the shape of a regular polygon. And if, just to remind you, a regular polygon is a polygon that has same angle measures and same side lengths. And so let's take a look at some definitions first. So if I look at this thing, a radius of a regular polygon is going to be one of these guys, from the center of the regular polygon to one of the vertices of the regular polygon. That is a radius. It's a segment joining the center to any vertex. The apothem is defined as a segment that joins from the center of the regular polygon to the midpoint of one of the sides of the regular polygon. And so if I look at the problem like this one up here on top, and I want to find the area of a regular hexagon, the side of 8, one thing I can do here is I can recognize that if I split this regular polygon up into a bunch of triangles, I'm going to end up with a whole bunch of equilateral triangles. And I know that because each of these angles here is going to be 120 degrees, so each of these angles are going to be 60 degrees, and all these lengths will therefore end up being the same. So if I have a hexagon with regular hexagon with a side length of 8, so this is 8, I have a bunch of 30, 60, 90 triangles right here. And doing some 30, 60, 90 magic, I can go ahead and I can recognize that this length is going to be 4, so this will be 4 root 3. And so I can do the area is equal to 1/2 base times the height, which is 8 times 4 root 3. And that's going to be the area of one of the triangles, and I just multiply that by 6. And when I go ahead and finish that, I'm going to end up with 96 root 3 as my answer. Now there's also, I can use the fact that, just a reminder here, just the fact that each of these equilateral triangles over here is also, you can find the area by doing s squared root 3 over 4. And so I can plug in the side length, which is 8, so it's going to be 64 root 3 over 4, or that each of these triangles has an area of 16 root 3, and then multiply that by 6, and you're still going to end up with 96 root 3. There's also a handy-dandy area of a regular polygon formula, and I'm just going to go ahead and show you that if I have, let's go ahead and erase this here. If I have one of these triangles here, and let's call this side length S, and let's call this little a for apothem. I know it's going to be 1/2 of the side length times the apothem, and I just multiply that by the number of sides. In this case, it's going to be 6, or the number of triangles. And so if I go ahead and simplify that, I know that the perimeter is just going to be 6 times the side. That's the perimeter. And so the final formula is going to be 1/2 still is there. The apothem is still there. And 6 times the side, or the number of sides, times 1 length of a side is just going to be the perimeter. So the formula for the area of a regular polygon is also 1/2 the apothem times the perimeter. And so if I want to use that, let's go ahead and use that in an example problem. Find the area of a regular hexagon with a side length of 10 centimeters. So here's my hexagon. Side length is 10. And if I go ahead and draw in an apothem there, I get a 30, 60, 90 triangle, some magic going on there. So this ends up being 5√3. So the area of this regular hexagon is going to be 1/2 of the apothem, 5√3, times 10 times 6, or 60. And I go ahead and simplify that. I get 150 times the square root of 3. Let's try a few more problems here. So problem number 2 here, side length, side of a square is 8. So curiously enough, an apothem would be drawn like that. The apothem length is 4. If I want to find the circumference of the inscribed circle, so you got a circle on the inside, like this. And I know that the radius is the same of that red circle is the same thing as the apothem of the square, which was 4. And so I know that the circumference is just going to be 2 pi r, or 8 pi. Now if I want to find the circumference of the circumscribed circle, so the circle that goes around the square, like this, then I know that the radius in this case is going to be right here, and the radius is the same thing as if I focus on the square, the purple square, it's the radius of that purple square. And so if this has a length of 4, this has a length of 4 also, that must be 4 times the square root of 2. 45, 45, 90 triangle. And so I can go ahead and do circumference is equal to 2 pi, the radius is 4√2, or if I simplify this, 8√2 pi to get an exact answer. Alright, let's do one more problem here on the bottom. Find the perimeter of a regular polygon whose area is 64. Let's use the formula here. Area is equal to 1/2 the apothem times the perimeter. And it's going to be 1/2. The apothem is 4. P is what we're looking for, and the area is 64. Solve for P. If I go ahead and solve for P there, P is going to end up being equal to 32. Alright, let's flip over to the backside and try maybe a couple problems on the backside. Okay, moving to the backside of this thing. Looking at problem number 4 here, there's 3 parts to it. Finding the length of one side and the apothem. So the first one's easy, it's a square with a area of 21, which makes the side length 11, and of course the apothem is just going to be half of that, 5.5. Easy start. Equilateral triangle, whose area is 36√3. Let's do an s squared root 3 over 4. Use that formula. Divide both sides by root 3, multiply by 4 on both sides. I get 144 equals s squared. So s is equal to 12. So that side length is 12. Then I can go ahead and break it down to find the apothem of this thing. This is going to be a 60-degree angle on all 3 vertices of the equilateral triangle, and so that means that this is a 30-degree angle right there. This is 6, so that means that 6 is opposite of the 60-degree angle, which is right here, and so it's going to be x times root 3 is equal to 6, or x is equal to 2√3. That, of course, is that side, which is the same as my apothem. Let's move on to the regular hexagon. So I got a regular hexagon here, and the perimeter is 24, so I know each side has to be divided by 6. So it's going to be just 4 for each side. And then if I want to find the apothem here, I have a, this is the apothem. Let's break it down. Let's kind of draw that triangle here. The side length of 4, and what we're looking for is this apothem right there. This is 2. This is a 60-degree angle here, so I know that this is going to be equal to 2 root 3, and so that's equal to my apothem. And of course, if I wanted to find the area just for fun, I could do area is equal to half of the apothem, 2 root 3, times the perimeter that we're given, 24, and I can go ahead and find the area, which is just going to be 24 root 3, just for fun. I think I'm going to stop there, and let's go ahead and let you try some of the problems from the section. All right, take care, please.